Hello everyone, and welcome to week 4 Exponents 1 video. Hopefully you all have gone through all of the reading materials and become familiar with the laws and rules of exponents. We'll use some of those in these examples. Okay, with this first example we have 3x squared y times 2x to the third all over xy to the third, and we want to simplify this to where we only have the x variable to appear once and the y variable to appear once, and we want to combine these numbers. So we can move these numbers and bases around like so. 3 times 2, x squared times x to the third, and then y. Just kind of put my like variables together. Alright, so we have 3 times 2 is 6. When we multiply like basis, we add the exponents, so that makes x to the fifth, y. Now there's a couple of different ways you can go from here, so I'm just going to move my x and y to the third up to the top. Now anytime you move a base over the fraction bar, the sign of the exponent changes. So that makes 6x to the fifth, and when I bring this x to the first up, that'll make x to the negative first. And then y to the first, and when I bring the y to the third up, that'll make y to the negative third. Now I can combine these x's and y's by using the same rule that we started off with. When we multiply like basis, we add the exponents. So 5 plus negative 1 is simply 4, and y plus 1 plus negative 3 is simply negative 2. Now in our final answers, we don't want any negative exponents, so anytime you have a base with a negative exponent, you need to rewrite it by moving it from wherever it is. In this case, I have a y to the negative second in my numerator. So in order to rewrite that with using a positive exponent, I will move it down to my denominator. And this will be my answer. Remember, anytime you move a base over the fraction bar, either up or down, the sign changes. So by moving this down underneath my 6x to the fourth, that'll make that a positive exponent, y to the positive second power. And this will be fully simplified. That will be your answer. Okay. X to the fourth y squared over x to the negative second, z to the negative second. Well, let's start off by moving these variables up. And remember, when I move these up, that's going to change the sign of my exponents. So I'll have x to the fourth, move my x to the negative second up over the fraction bar, that'll make x to the second. Then I'll have y to the second, move my z to the negative second up over the fraction bar, and that'll make z to the positive second power. Now the only other thing I can do to simplify this one is to combine this x to the fourth and x to the second. Remember, when we multiply like basis, we simply add the exponents. That gives us x to the sixth, y squared, z to the second. And this will be considered to be simplified. Okay. Alright, 4x squared y all raised to the third power. I like to think of this as kind of like distributive property. This exponent on the outside will be distributed to each one of these on the inside, each base on the inside. So this is really 4 to the third power, x to the second raised to the third power, and y to the first raised to the third power. Now 4 to the third power is just 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. X squared raised to the third power, we use what we call the power to a power rule. When we have an exponent on the inside of the parentheses and it's raised to an exponent directly outside the parentheses, you just multiply the two exponents to simplify that. So that makes x to the sixth. Again here, y to the first power raised to the third power, power to a power. We multiply those exponents, and we get y to the third power. And this will be simplified. 64, x to the sixth, y to the third. Okay, so what we've done is we've used the like basis rule. When we multiply like basis, we add the exponents. We've also used the rule of moving basis over the fraction bar. Anytime we move a base either up or down over the fraction bar, the sign of the exponent changes from whatever it is. And we use the power to a power rule. Everything gets distributed to the power outside the parentheses, and if you have an exponent raised to another exponent, you just multiply them to simplify. Alright, that's it for Exponent 1 video.